Hey guys, this is Anthony. I'm showing you guys again how to walk through finding our percent abundances when I give you the average atomic mass from the periodic table. So here's our sample problem. Antimony with symbol Sb has an average atomic mass of 121.8 AMUs. Its first isotope has a mass of 115 AMU, while its second isotope has a mass of 125 AMUs. What are the percent abundances for the two isotopes? So we're going to start again with our generic formula of average atomic mass, so 121.8, is equal to the mass of the first isotope, 115, times its percent abundance, which we don't know, so we're going to call it X. We're going to add that to the mass of the second isotope, which is 125 AMU, and we're going to multiply that one by its percent abundance. Since it's a new percent abundance, we're going to call it Y. Make sure you divide by 100, because we want everything to be in our decimal form. Now if we write our second equation, x plus y, we know that those have to equal 100%, because whenever we have percent, it means per 100, so x plus y are going to equal 100. If I rearrange this and solve for y, I get 100 minus x, because I subtracted x from both sides. Now that we have two equations, we're going to take our second one and plug it in for y. So if I rewrite this, I get 121.8 is equal to 115x plus 125 times whatever y equals. Now we know y equals 100 minus x. And remember, these are divided by 100. To get rid of these 100s in the bottom, this one here and this one here, we're going to multiply by 100. Whatever I do to one side of my equation, I have to do to the other. 100 times 121.8, I know I'm going to move my decimal 2 times. So there's my first time, my second time. Now this is gone and this is gone because they canceled out with that 100 in the blue. So I now have 115x plus 125 times 100 minus x. From there, we are going to distribute. So this needs to go here and here. So we're going to write down 115x
Corporal Hoffman, would you please
plus
come to the main office
125.
Deputy Hoffman.
125 times 100, again, I add my two zeros. And then negative x times 125 is negative 125x. And that is still equal to 12,180. Oh, that jumped up pretty high. Now we're just going to keep going with our math. So I am going to combine my like terms. So we're going to keep this number. Now I have 115x minus 125. So if off to the side I have sorry about that. I have 115 minus 125. I know that that's going to be negative 10. So I have negative 10x plus 12,500. Next, I'm going to subtract this 12,500 from both sides. When I do that, I get, well, what's 180 minus 500? I'm going to work backwards and do 500 minus 180 and just turn it into the negative. So another 20 gets me to 200, another 300 gets me to 500. So I know I'm going to be at 320. Remember, I'm doing a smaller number minus a bigger number, so it's going to give me a negative, is equal to negative 10x. Now my 10 is being multiplied by this x, so I'm going to divide everything by negative 10x. When I divide 320 by negative 10, and that's a 10, I get 32 is equal to x, and that is a percent. If I go back to my original equation, right, so I at one point had y is equal to 100 minus x, I now have an x value. So y is equal to 100 minus 32%. Therefore, y is equal to 68. is 68. 2 more gets me up to 70, plus 3 more gives me up to 100. So this is one of my answers, and this is the other answer. Now the best way to do it is to make sure that we add in what it is representing. So if we go back to the beginning of the question, I have SB and 115 and SB and 125. So I'm going to go back down to the bottom. This one represents SB 115, and this one represents SB 125. And we're done. Use this sample to go through the problem from today in class, and hopefully you can follow through with your own numbers. If you cannot get it, come see me after school tomorrow.